3.
Hi, my team and I are going to talk about polynomial functions grade 3. But first, what is a function?
3.
A function is a mathematical expression where the y is dependent of the x and the x is independent of the y. This means that the x is going to give the value of y depending on certain rules that we can apply in the function. We can also call the x and y the domain and the range. For example, we have here a graph where the x is the domain and the y is the range. Each value of y will be chosen by the position of x in this graph.
There are different types of polynomial functions. What tells us the grade of a polynomial function is the biggest exponent of the x. For example, in this first one, f of x equals x plus 1. So the biggest exponent of the x is 1. This means this polynomial function is degree 1. In the second example, we can see that the biggest exponent of x is 2. So this one is degree 2. On the third example, the biggest exponent of x is 3. So we can say that this function is degree 3. And on the last example, the biggest exponent is 4. So this polynomial function is grade 4. In this project, we are going to talk about specifically about polynomial functions of the third degree.
So, this is the problem we came up with in order to explain what are the polynomial functions of a degree 3. Well, we make this problem in order to show you how they work, how can you solve them, and how you can obtain the range and domain of said function.
Well, we have a cube with x length. The volume of this cube is not exact. If you subtract x to the whole volume, you get the correct volume of said cube.
Here is the cube of our problem. As we can see, all sides are x, because in a cube, all the sides are the same. There is a part missing in our cube. This part is also equal to x. To solve this problem, we have to get first the volume, which is x to the cube, but we do have a part missing. So this means it is minus x.
With this information that Javier just gave us, we can get the formula of this function. We can say that f of x equals x cubed minus x. So, with this function, we will be able to graph it and we can see the different results that we can get depending on the different lengths of each side of the cube. So, in order to solve this function, we need to establish a table where we give x a certain range of values. In this example, I am going to use minus 2 to 2 in order to make it more simple and faster to do. So, our function is f of x equals cubic x minus x. So, we are going to get the value of y for all of these numbers. First, I'm going to take the value of y in the number 1. So how do we make that? We just need to substitute the x by the values here. In this case, the 1. So f of 1 equals 1 cubic minus 1. This will be f of 1 equals 0. So now that we have this value, we are going to write it here. Now, what are we going to do? So a little dot here in 1, because x is equal to 1, and because the y is equal to 0, we're going to leave the 0 right here.
So the next step is do the same thing right here, but with all these numbers.
Now that we have obtained all the values repeating the same process over and over again, we can finally put the coordinates where they have to be in the graph. In x minus 2, the y is minus 6, so we have to locate x minus 2, y minus 6. In x minus 1, y is 0, so we put it here. In x0, y is also 0. In x1, y is 0, we already have that point here. And in x2, y is 6, So we put it up here.
Now, to finish the graph, we have to draw the line.
Now that we have our graph and values complete, what do they mean? This means that when our value of x in the cube is -2, our volume will be -6. If our value of x in the cube is -1, our volume is 0, as well as when x is 0 or 1. All three volumes are 0. And when the value of x in our cube is 2, our volume is 6.
As Javier explained, we can make the same thing that we make in this table, but with all the numbers. We just need to substitute the x with the number that we want in this table. Now, the last step, we need to take the domain and the range. So how do we find the domain and the range? This is really simple now that we have the graph. We need to remember that the domain is this whole line, the x, and the range is this whole line, the y. So we can see that these both lines are growing infinitely both to the line x and to the line y. So we can say that the domain and range are infinite. So how do we write these things? Domain equals minus infinite to infinite, because this will be continue growing till infinite. And now the range is going to be minus infinite to infinite, because this will be continue growing to infinite. And with these two things, we can finish this problem.